Awe, this is part 67 of my aluminium lamp design. And I'll start by modeling part 7, which is a T25 module 2.5 Spur Gear. Please note that in this video I'll be using a metric unit system. But before sketching anything, let's look at a few terminologies. So we have what we call a module. What is a module? The module is the pitch diameter in millimeters divided by the number of teeth. And it is the metric equivalent of the diametral pitch which they use in the imperial system. And please note that the module is equal to an addendum. And what is an addendum? Addendum is the radial distance from the pitch circle to the top of the tooth. But what is a pitch circle? A pitch circle is an imaginary circle on which two mating gears roll together. And this addendum is just one part of the full depth of a gear tooth. What about the other depth? That one we call a dedendum. The dedendum is the radial distance from the pitch circle to the bottom of the tooth. And when you add those two together, you get the full depth of the gear tooth. Okay, now that we have that in place, let's go to equations. And under equations, you're going to add two global variables. The first global variable will be the module M, which in our case is 2.5 millimeters. And the second global variable will be the number of teeth, T, which is 25 in our case. And please don't add any units after the 25 on the number of teeth, because this number just tells us how many teeth the gear has. So we're just counting the number of teeth. Then press OK. Now we return to our sketch. You open sketch on your front plane. On this sketch, you're going to sketch only 3 circles. And what are those circles? The pitch circle, the addendum circle, and the dedendum circle. So I'll be using mouse gestures. Right click, hold, circle. Okay, now let's use Smart Dimension to dimension these circles, starting with the PCD. And the formula to calculate the PCD is the number of teeth multiplied by the module. So I'm going to say equal number of teeth, T, multiplied by the module. Press OK. And that's our PCD. And then next we dimension our addendum circle. And the addendum circle is the PCD plus 2 times the module. So going to say open bracket, number of teeth multiplied by the module plus 2 times the module. Then press OK. Okay, now that we have those 2 circles dimensioned, what about that circle? So on this one, we are not going to dimension the diameter, but are going to dimension the full depth, since we know that the full depth of a gear tooth is the addendum plus the dedendum. Okay. Right, so now you're going to say the module M times, then use the if statement. Use the if statement that you should multiply the module if the module is equal or greater than 1.25. Then you multiply it by 2.25. And if that's not the case, then you should multiply it by 2.4. Then press enter. And there you have your full depth. Okay, then now right click, extrude. And on selected contours, select this outside diameter and choose mid plane is 20. Press OK. And there you have your round bar. Then now we are going to create a cutout. So you're going to open sketch on your front plane. A vertical center line. Then after doing that, you're going to sketch an arc on this side as well as this side. But to easily sketch that arc on both sides, you can select dynamic mirror entities and choose this vertical center line. Now select your 3-point arc, then sketch an arc on this side, and it will automatically sketch an arc on the other side because we used dynamic mirror entities. Okay, now that we have that, we can turn on this sketch to help us. Then now convert entities for your Didendum circle. Convert entities. Why do we do that? So that we can make this point to be coincident with this circle. Like that. And then you're going to offset your outside diameter. Offset this outside diameter, let's say maybe to a distance of 3 millimeters. Why do we offset? To make sure that this point, coincident with this circle. Coincident. There we go. And then after that, going to go to trim entities. You trim this part of the circle, so there's this part of the circle, and what you're left with is only this. Okay. After doing that, now you sketch a horizontal construction line from here to roughly here. The distance doesn't matter. And why are we sketching this construction circle? To make sure that this point always exists where this arc and this circle, the PCD, intersect. There we go. And then after doing that, you're going to sketch another construction line from the origin from the origin up to this point of the arc, this point. And then after doing that, you select this construction line as well as this arc and make them tangent to one another. Make tangent. But we don't need this one. Yeah, so okay. And then after doing that, now you have this. Then you're going to sketch another construction circle from roughly here, doesn't matter where, up to that arc. And you make this line to be tangent to this arc. Tangent. You select that line again and make sure that it is coincident. But before that, let's snap this in place. Snap this point. Yeah. Select this line. Select this point. And make coincident. And then after doing that, we are going to give this line an angle. And that angle is our pressure angle, or PA. So you select that line using smart dimensions and your vertical center line. In our case, the pressure angle is 20. There we go. Now let me move this to this side. Yeah. Just like that, 20 degrees. Okay. And then now what we are left with is to dimension only one construction line here. And that construction line is what we call caudal thickness of a gear tooth. And what is a caudal thickness? Caudal thickness is the PCD sine 90 degrees over the number of teeth. So we're going to say equal the number of teeth, because the PCD is the number of teeth multiplied by the module. So open brackets, T multiplied by M times sine at the sine function, sine 90 DEG space over the number of teeth. There you have it. And that's your caudal thickness. Then now our sketch turns black to show that it is fully defined. You go to your features, extrude cut, choose through or both, press OK. Let's hide the sketch. And there you have your gear tooth cut out. This is a cut out. Now we will add a fillet on this edge as well as on this edge. Do that right mouse click, hold, fillet. Then you're going to use a formula for this, and that formula is equal 0.3 times your module 2.5. This edge, lay this other edge. Shiwe, monate. Honagamku. And then after doing that, our gear has a chamfer. So we're going to add a chamfer. Right click, mouse, hold, chamfer. And in our case, the chamfer is given as 1 millimeter at 45 degrees. So chamfer is 1 millimeter at 45 degrees. Then press OK. Sharp. And then now we can circular pattern the cutout and the fillet. And to do that, going to go to circular pattern. And under features, you're going to select the fillet as well as the cutout. Fillet, cutout. And direction, select this face. And then on the number of instances, we are going to use the global variable, which is T, global variable T. So that next time when you want to maybe change the number of teeth to a different number other than 25, it can adjust without breaking the model. Press OK, and then done. There's your gear. Now let's open a hole here, an ID inside diameter of 18. And when I was manufacturing this gear, we used what you call a rimmer and rimmed this hole at 18, exactly 18 millimeters. So 18. Press OK. Then go to features, extruded cut. And then choose through all. Press OK. And there's your gear. Let's apply appearances. Motion study. There's our gear.